Here is the next example on Bernoulli differential equation. It looks like a simple, but it is very tricky question. So let's see how to solve this example. Again, first write down in a standard form. So first term we want dy by dx without containing x. So this bracket you have to divide. So here firstly I will divide. To understand, I will write stepwise. So first divide by 1 minus x square throughout. So when we divide 1 minus x square, the first term is dy by dx plus x divided by 1 minus x square into y equal to x divided by 1 minus x square into y square. Now in the next step, here right side we want only function of x, but here it is a y square, that means again divide by y square. So in the next step we divide by y square. If you understand this type of question, so directly in a first step you can divide 1 minus x square into y square at a time. If we divide by y square both sides, so you will get 1 upon y square dy by dx plus x 1 minus x square, and here y divided by y square, so 1 y get cancel out, equal to x 1 minus x square. And check whether this function of y, its derivative present in the first term. If it is, that means it is correct and it is possible to reduce into the linear form. So 1 upon y's derivative is, it is in the form of 1 upon y square, and it is already present in the first term. That means to convert this equation into the linear form, we have to put 1 by y as a new variable v, and its derivative, here derivative of 1 by x formula is minus 1 by x square. So using that formula, if we differentiate this term with respect to x, so here 1 upon y derivative is minus 1 by y square dy by dx equal to dv by dx. So this minus sign multiply, because here our first term not containing minus sign, so that's why we have to multiply by minus. So you will get 1 by y square dy by dx equal to minus dv by dx, and put this value in this differential equation. So the first term is minus dv by dx plus x upon 1 minus x square into, here it is a v, 1 upon y is v, equal to x 1 minus x square. Now for standard form, again here only we want dy by dx, not any minus sign, any constant or any function. So in the next step multiply by minus. So throughout multiply by minus, so you will get dv by dx minus x upon 1 minus x square into v equal to minus x upon 1 minus x square. Now to make it simple, you can take the minus sign common from this bracket, so that this become plus. So in the next step, if we take minus sign common, so you will get here dv by dx plus x upon x square plus 1, x square minus 1. Here we are taking minus sign common, so it become a x square minus 1, and that minus sign and outside minus become plus into v. Similarly in the right side, x upon x square minus 1. Now it is a standard form of linear differential equation. We know that linear differential equation, if we write in the form of v, then it is a dv by dx plus p of x into v equal to q of x. Compare this equation with this form. So coefficient of v is nothing but function p. So here p is become x upon x square minus 1, and function q is the right side term. So function q is x upon x square minus 1. Using this, you have to find out integrating factor. That is our first step. So integrating factor formula is e power integration of p dx. So here it is a e power integration of x upon x square minus 1 dx. Can you solve this integration directly? Yes. Many times I have discussed this type of formula, that denominator derivative present in the numerator, then it become a directly log of that function. And now see here, x square minus 1, if we consider x square minus 1 as a t, then its derivative 2x dx become dt. Now here it is a x dx already there, so you just have to adjust 2. So if we adjust the 2, multiply and divide by 2, so it 1 upon 2 and 2x divided by x square minus 1. So what is the formula of integration? Here I am using integration of f dash x upon f of x, derivative of denominator present in the numerator, then it become a log of function. So it is a log of f of x. Here is the same condition, x square minus 1, its derivative is 2x present in the numerator. So we can say it is a e power 1 by 2 outside term as it is, log of x square minus 1. And if we shift this 1 by 2 in the power of x square minus 1, so you will get here e power log of x square minus 1 by 2, and e power log is nothing but function. So therefore our integrating factor become root of x square minus 1. So this is our integrating factor. Now after that you have to write its complete solution. So I will write in the next step. After getting integrating factor, we have to write its complete solution. For this linear differential equation, complete solution become v into integrating factor equals to integration of integrating factor into q dx plus integrating constant c. So we know the integrating factor as well as function q. So put this value here. So v integrating factor is root of x square minus 1 equals to integration of, here integrating factor is our x square minus 1 power root means 1 by 2 and q is x upon x square minus 1 dx plus c. Now this term is contained in root and here it is without root. Can we cancel out one term? So if we cancel out this bracket with this term, so you will get here power 1 by 2. So I will rewrite in the next step. So here if we cancel out this term with this bracket, so you will get x upon root of x square minus 1 dx plus c. Now in the next step, solve this integration, and to solve this integration we can put this x square minus 1 as a new variable t. If we put x square minus 1 equals to t, then its derivative 2x dx equal to dt. So here x dx become dt divided by 2. So put this value here in the integral to solve this integral. So dt divided by 2 I will write in the outside integration, and dt divided by 2 is value of x dx, and this root term is our t power 1 by 2. Root means power 1 by 2 plus integrating constant c. Here integration of x power n is x power n plus 1 divided by n plus 1. Here t power 1 by 2 you can shift you can write as a 1 by 2 outside constant t power minus 1 by 2 dt plus 1. And to solve this integration, use this formula, x power n is x power n plus 1 divided by n plus 1. So here it is a 1 by 2 t power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus c. And we know that minus 1 by 2 plus 1 is nothing but 1 by 2. So this is a 1 by 2 and here it is a 1 by 2. So this 1 by 2 get cancel out. Remaining is, it is a t power 1 by 2 plus c. And left side is v into root of x square minus 1. Now v is 1 upon y. So put the value of v because we want the answer in the form of x and y. So here v is 1 upon y. So x square minus 1 root of x square minus 1 divided by v equal to right side t, and t is again here t is our x square minus y. So root of x square minus y plus integrating constant c. So this is the final solution of our given differential equation. In this way you can solve the Bernoulli differential equation. In next coming video we will discuss reducible to linear differential equation question. So thank you for watching. If you are new on my channel, subscribe the channel, click on the bell icon so that you will get the notification of my next coming video. Thank you.